Hello, everyone. Welcome to Lab 10. And this week we're going to be covering analysis of airborne and satellite imagery. This lab has two different concepts, so I'm going to split these videos into two just so it'll be easier to go back and look or track what you've covered and what we haven't. But we'll go ahead and get started. We're going to start with remote sensing. So remote sensing is a collection of data describing features or phenomena of Earth's surface and near the surface without direct contact. Satellite images, as you can see in the picture right here, is one example of that. So there's two types of remote sensing we're going to get into for this lab. The first is airborne, and this is done from an airplane or balloon or even drones nowadays. And it's higher spatial resolution because it's closer to the surface of the Earth, and the pixel size is smaller compared to that of our second, which is satellite. So since the satellite is way above Earth than the land that it's taking pictures of and tracking, it's lower spatial resolution and the pixel sizes are larger. Could still be high resolution up to 0.5 meters. However, airborne tends to have higher resolution and smaller pixel size. And then two other terms to be familiar with is nadir, and that is directly below aircraft or satellite. You can see the example right here. And then oblique, and that's a side view from the aircraft of the satellite. So you can go ahead and see those examples right here to the right. So spatial resolution, remember, airborne has higher res with smaller pixel and satellite is lower res with higher pixel. And spatial resolution is just degree of detail visible in photographs or film. An advantage of resolution, smaller file size. So lower res, remember, that would be more satellite. Smaller file size loads large objects more quickly and can cover a larger area, but there's also advantages to high resolution that includes more accuracy and more detail. Lower res, fewer and larger pixels. High res, more small pixels. You could see right here between a megapixel down on the right, megapixel and analog resolution, and even the zooming in features, you could see the difference in the pixel. While megapixel or smaller pixels do have their benefits, if we're looking at a larger landform or over a bigger space and maybe physical geography, sometimes it is beneficial to be able to get a larger space and sacrifice the resolution. So something we're going to be examining in these images, these spatial images, is tone and color. And it's related to the amount of light reflected from the scene in a specific wavelength. It has to do with albedo, and that's the amount of energy or light that is reflected by a surface. And real world surfaces, you got to keep in mind, reflect different proportions of energy, and that explains why they look different in color. So an example of this would be snow. Snow has really high albedo effect because it reflects a lot of light because of its white. But if you got a blacktop or a big parking lot possibly that was covered in asphalt, it's going to absorb more light. So you could see down here on the bottom, two different types of ways we could view the same image, right? So like I said before, albedo, high albedo, light surfaces, so like snow, low albedo, dark surfaces. So over here on the right, you're going to get a much higher albedo effect that it's going to reflect. And then without snow or ice, it absorbs more heat. So just this grassland over here. So texture. So texture and tones, but same tones doesn't mean they have the same textures. So it's smooth, intermediate, or coarse are words we use for it, heterogeneous versus homogeneous. And then we have function of scale and ability of the interpreter. So that's just an outline of this slide, and now I'll go over each one specifically. So if you look over here to the right, these are two different tones, right? This one, you have the same texture. It's like foresty, but this is a lot lighter than this. This is a lot darker, right? And then smooth, intermediate, or coarse. So for up here, I would say this is a coarse texture. And then if you look at this one down here, there's different types. Yeah, there's different types of textures within the same image. One of the things about these different categories, it's going to depend on who's looking at it. Everyone might have a little bit of a different eye for it or a different classification. So as long as you answer these questions on the lab and show that you put in effort, I will be flexible in grading it. Then we have heterogeneous versus homogeneous, and that's different textures in the same image or the same. So I would say the top one is definitely more homogeneous. There might be a little bit of different, and then the bottom one right here is definitely heterogeneous, right? We have some smooth, maybe with this dirt or this grass, but then we have coarse, maybe some intermediate places. Yeah, once again, it's up to the person, but that's how you would analyze this. And then, yeah, function and scale. So the scales, something might look a lot more rough or coarse. The closer you get to it, might look a lot more smooth when you zoom out, right? So it depends on the scale of these images. And then once again, it's the ability of the interpreter. It depends on who's looking at this image. And that's going to, tell that whoever's looking at it, it's going to be different. Pattern. Okay, so here's another way we're going to describe this. So spatial arrangement of the features in landscape. If you look at these 6, obviously they all have different patterns, right? But how are we going to categorize these? So we're going to either call them geometric or irregular. Geometric would be like this one right here. This is definitely more of a geometric pattern. And right down here is irregular, right? There's not really a flow or a pattern, a regular pattern in that one. So generally speaking, irregular is more of natural systems. So if you're just getting a picture of a forest, and geometric is more human-made. It's organization, right? Same here. I would argue this is more geometric as well. This one, more irregular. This one might be a mix, but it could help, categorizing these patterns can help us identify drainage patterns, neighborhoods, agricultural fields, etc. So just knowing could help us identify what this piece of land is being used for. So these are the 6 different things that we use to describe it. There's the shape, size, and association, but for this lab, it's mainly going to be focused on tone, texture, and pattern. So let's look at this one, right? We have this is what my answers would have been for this. I would have said darker, all these trees, it's a little darker. The pattern's regular, it looks like a neighborhood. There's streets all sectioned off. And I would say the pattern is rough. It changes from each, meter to the next, each block to the next. It's a different pattern. It's not smooth. But maybe if you looked at this, you would have said, oh, it's a little lighter. Maybe it's a mix. Maybe it's a darker, but not dark. Maybe you would have said intermediate instead of rough, and that's okay. Once again, it depends on who's looking at these. Here's a good example of mixed stuff that also is a lot of room up to interpretation. So tone, light, look at all these salt pools. I would say this is more of light. Once again, you might say it's light or a mix because you have these forests over here. So texture, rough on the east side, right over here and over here, all that rough pattern. But smooth, where the salt pools and water are, that's all very smooth, right? And pattern, irregular. This all changes from each section direct from that, right? These houses are definitely irregular. These forests are irregular, but then maybe you say regular for the water. And you could put all of that down when you're answering these questions, but this is just an example of how much this is left up to interpretation, just depending on who's analyzing it. And then this is just an example. In some GIS images, it's going to be coded so vegetation is red, so it appears as red. This is happening when we want to notice where the vegetation is, or maybe the analysis you're doing has a lot to do with the vegetation or where it shows up, or maybe you want to be able to pull that out. So this is sometimes vegetation is coded as red, so it's false color imaging. But the tone, I would say, is light in this one. Texture, definitely rough, and pattern, very, very irregular. It's an informal settlement is what it's going to be known as, and then once the vegetation is coded in red. Here's one more. You can see there's a lot more vegetation that's showing up in this. The red is definitely helping us notice that. Tone, medium. Yeah, it's light in some places, dark in others. The vegetation is red, rough, not smooth at all. And the pattern, it looks like it's pretty regular. It looks like this could be a neighborhood, somewhere in a suburb, probably. Okay, and that concludes our first video, and I will start the next video soon, right after this, and we will be going into landforms.